Here at the mouth of the Yellow River sits one of China's largest oil fields. China has once again achieved an engineering marvel that seems almost unreal. Imagine extracting billions of tons of soil from beneath a river to create an underground passage. For most countries, such an undertaking would be unthinkable, but for China, it's just another challenge to overcome. This is a country known for taking on seemingly impossible projects, from constructing the Great Wall to building futuristic mega-cities. Yet this latest feat may surpass them all, not just because of the scale of excavation, but because of what was built inside it. Jinan, a city of nearly 9 million people, is divided by the mighty Yellow River, a 5,400 kilometers long force of nature that has sustained civilizations for thousands of years while also serving as a major transportation barrier. With the city expanding at an extraordinary rate, bridges alone were no longer sufficient to keep up with the demand. Traffic congestion remained a constant struggle, travel times were unbearable, and existing infrastructure was outdated. Instead of constructing yet another bridge, China took a more ambitious approach, tunneling under the unpredictable and flood-prone Yellow River. Given the immense technical difficulties involved, this would have been deemed impossible elsewhere, but China made it happen, removing an unimaginable volume of soil without causing a catastrophe. Jinan's rapid growth was constrained by geography. The southern part of the city was packed, surrounded by mountains that made expansion difficult, while the north had ample space for development. The Yellow River created a major obstacle, making it hard to connect the two regions. This wasn't just a minor inconvenience, it was stalling economic growth. The northern districts had over 100 square kilometers of underutilized land, but without seamless connectivity to the city center, investments were sluggish. Bridges and additional roads had been tried, but congestion persisted. A more radical solution was needed. The Jinan Yellow River Tunnel changed everything. More than just a shortcut, it is a game-changing piece of infrastructure. Unlike conventional tunnels, this one is a two-level structure designed to accommodate both a highway and a high-speed metro line. This unique design not only maximized efficiency but also minimized costs compared to digging two separate tunnels. The top level carries a 6-lane road for vehicles, while the lower level houses a railway for fast, uninterrupted transport. Achieving this level of complexity under a turbulent river was nothing short of an engineering masterpiece. In terms of scale, this tunnel sets a new global benchmark. While Switzerland's Gotthard-Base tunnel is longer at 57 kilometers, it is rail-only. The Channel Tunnel between the UK and France is also impressive but exclusively designed for trains. Even Japan's Tokyo Bay Aqua Line, another underwater tunnel road combination, spans just 9.6 kilometers. The Jinan Tunnel surpasses them all at 10.9 kilometers, earning it the title of the longest two-level tunnel beneath a river. By stacking the road and subway, engineers saved both space and money, ensuring a smarter and more cost-effective approach. If two separate tunnels had been constructed, expenses would have skyrocketed. Instead, China delivered a cutting-edge solution that is both practical and efficient. For millions of residents, the impact is immediate, travel times have been slashed, connectivity has improved, and the city is finally able to expand seamlessly. Constructing any tunnel is a formidable task, but creating a 10.9 kilometers double-deck tunnel beneath the Yellow River presented unprecedented challenges. The river's silt-heavy waters make it one of the muddiest in the world, carrying 1.6 billion tons of sediment annually. The ground beneath it is highly unstable and prone to collapse, making excavation extraordinarily risky. Conventional tunneling methods would have been insufficient, requiring a more innovative approach. To tackle this, engineers deployed a colossal 4,100-ton tunnel boring machine designed specifically for the project. With a diameter of 15.5 m, large enough to fit a double-decker bus, it was built to carve through unstable sludge while simultaneously reinforcing the tunnel walls. This meant no interruptions as the machine continuously advanced while installing massive precast concrete segments in real time. Yet even with state-of-the-art equipment, groundwater pressure posed another significant threat. The forces acting on the tunnel could have crushed an unprotected structure instantly. To prevent this, engineers developed a sophisticated stabilization strategy. Before the tunnel boring machine even reached a section, the soil was injected with a special grout mixture to firm it up, reducing the risk of collapse. It was an ingenious approach that ensured safety and structural integrity throughout the process. China has not only built one of the most advanced tunnels in the world but has also done so with a level of precision and efficiency that sets new industry standards. This project is more than an engineering triumph, it is a symbol of China's ability to push boundaries and redefine what is possible. With this tunnel now in operation, Jinan is no longer constrained by its geography. The city's future growth is unlocked, and the impossible has once again been made possible. To prevent water from flooding the tunnel, engineers used air pressure control, essentially creating an artificial force inside to counteract the immense pressure from above. Imagine holding back a flood by blasting air into its face. It worked flawlessly. Not only did they carve through the unstable sludge, but they also managed to keep the river exactly where it belonged, above them. But the challenge didn't end with excavation. The structure had to be seamlessly connected across 2 levels, strong enough to handle thousands of vehicles and a subway system daily, and resistant to any potential shifts over time. This required ultra-high-strength concrete for reinforcement, cutting-edge waterproofing, and a floating track system to reduce subway vibrations. Even with these complexities, the project finished ahead of schedule. This wasn't just another tunnel. It was a groundbreaking engineering achievement that set new standards for infrastructure worldwide. By the time it was complete, it wasn't only the longest 2-level river tunnel, it became a model for future mega projects. And this tunnel? It's just a piece of something even bigger. A key player in this accomplishment was the 4,100-ton tunnel boring machine, a technological marvel specifically designed for this extreme project. This wasn't just any machine, it was an earth-chewing giant built to navigate one of the most dangerous and unpredictable tunneling conditions imaginable. If you've ever seen a tunnel boring machine, those massive rotating cylinders covered in steel cutting wheels, picture that, but on steroids. This particular machine had a diameter of 15.5 m, making it wider than a 5-lane highway. If placed upright, it would stand taller than a 5-story building. But its sheer size wasn't its only impressive feature. It was engineered to excavate, reinforce, and seal the tunnel simultaneously. At its front, a massive rotating cutter head equipped with razor-sharp, high-strength teeth sliced through rock, clay, silt, and sand, breaking everything down into manageable debris. The real challenge, however, was the unstable, waterlogged mud beneath the river. Unlike solid rock, this material couldn't hold its shape after being excavated. To solve this, the machine immediately installed massive precast concrete segments behind the cutter head, locking them in place like giant Lego blocks. This process created a solid tunnel lining as it advanced, preventing cave-ins, collapses, or water intrusion from the river above. But the difficulties didn't stop there. The machine had to contend with immense groundwater pressure capable of crushing a submarine. Engineers. Beyond the tunnel, a glimpse into the future. The successful completion of the Jinan Yellow River Tunnel not only marks a significant milestone in engineering but also sets a precedent for future infrastructural projects worldwide. This achievement demonstrates how innovative engineering solutions can overcome natural barriers, potentially inspiring similar projects in other regions facing geographical challenges. Moreover, the tunnel's impact on Jinan's urban development is profound. By seamlessly connecting previously divided regions, it facilitates economic growth, improves accessibility, and enhances the quality of life for residents. This model of integrating transportation infrastructure with urban planning could serve as a blueprint for other rapidly growing cities. However, it's essential to consider the environmental implications of such large-scale projects. Continuous monitoring and adaptive management strategies will be crucial to mitigate any long-term ecological impacts on the Yellow River's ecosystem. Balancing development with environmental stewardship will remain a critical challenge moving forward.